Welcome to direct variations. This is one of the types of variation. I'm going to be showing you how to calculate problems as related to direct variations. So what do we mean by direct variation? A variation is said to be direct if an increase in one quantity leads to an increase in another quantity, or vice versa. For an instance, if you have quantity A and quantity B, if quantity A increases, that means B will also increase. And then if in the same vein quantity A decreases, it means quantity B will also decrease. Question on direct variation might come like this. They might say A is proportional to B, or A is directly proportional to B, or A varies directly as B. I want you to take note of is proportional to, is directly proportional to, varies directly as. When you see those sentences like that, when you see those phrases like that, you know that it's talking about direct variation. When you see those sentences like that, you know that it's talking about direct variation. Okay, let's try to make the explanation clearer by making use of given two quantities A and B. If A varies directly as B, then we can say mathematically that A is directly proportional to B. This sign here is the proportional sign, so that means we can say, if we remove this proportional sign, that means we can say A equals to KB. This simply means A equals to K times B, where K is a constant and A and B are quantities. This A equals to KB is called the connecting formula, or sometimes it can be called connecting relationship. So now, from here now, you can make K the subject of the formula. If you make K the subject of the formula, it will simply be K equals to A all over B. So if you're making K the subject of the formula, all you need to do is just you divide both sides by B. So when you divide both sides by B, that's this A by B and this KB by B. So B will cancel out at the right hand side and you have only K left. So you have K equals to A over B. Let's look at the first example on direct variation. Given that y varies directly as x, when s equals to 2, y equals to 8, find y when s equals to 13. In this question, I want you to take note of this statement, y varies directly as s. What does this signal to you? It simply means that this question is a direct variation question because of this statement varies directly. So that means we have y varies directly as s. This is the mathematical formula connecting them. So we have something like this, y equals to kx, where k is a constant. So from this formula, we can make k the subject of the formula, and then we have k equals to y divided by x. So if you're making k the subject of the formula, all you need to do is to divide both sides. You're dividing the left hand side by this x and dividing the right hand side by x. So the right hand side, s will cancel s out, and then you have k left there. We have k equals to y all over s there. The next thing to do now is to make use of this value. We are given the value of s equals 2 and y equals 8. So we are making use of these two values, s equals to 2 and y equals to 8, to determine the value of k. So we fix it into this formula here of k. So we now have k equals to, you know y is 8, so we put in 8 there, and then the 2. So we have k equals to 8 divided by 2. So 8 divided by 2 will give 4. So k equals to 4. When k equals to 4, the next thing to do now is to fix in the value of this k into this formula. So in order for us to get the connecting formula, we are making use of this y equals to ks. You know, we've gotten the value for k, so we fix in that k into this formula y equals to ks, and then we now have y equals to 4x. So this y equals to 4x is the connecting formula or the connecting relationship. Through this formula, we'll be able to find the value of y when s equals to 13. So we are given s equals to 13 and we want to know the value of y. So let's fix in the value of this 13 into this formula. Then we have y equals to 4 times 13. 4x here simply means 4 times x. So that's the reason why we have this times there. So 4 times 13, that means our y equals to 52. So 52 is our final answer there. Let's look at the example 2. If a varies directly as the cube root of b, and if a equals 3 when b equals 64, find the formula connecting the variables. Hence, find b when a equals to 15 divided by 4. In this question, if you look at, we are given the statement a varies directly as the cube root of b. So that's what we'll be working on. The varies directly here means that this question is on direct variation. Interpreting that mathematically, we have a varies directly as the cube root of b. So this is the symbol for cube root. We can interpret this as a equals to k cube root of b. This simply means k times cube root of b, where k is a constant. We can actually make k the subject of the formula. The reason why we're doing that, because we need to determine the value of k from this formula. To do that, all we need to do is to divide both sides by this cube root of b. So when we do that, the cube root of b will cancel out from the right hand side. The right hand side is this k times cube root of b, and the left hand side is having the a. So that means we have something like this: k equals to a divided by cube root of b. So the next thing to do now is to list out what we are given. We are given a to be 3 and b to be 64. So we're making use of these two values to determine the value of k, which is the constant. So we're going to fix in a equals to 3 into this formula here of the k. So we have k equals to 3 divided by cube root of 64. So you can use your calculator to do the cube root of 64 if you don't know it. But the cube root of 64 is 4. Cube root simply means that which same number will you multiply 3 times to give you 64. So the same number that you multiply 3 times that will give you 64 is 4. So 4 times 4 times 4, that will give you 64. So that means our k will be 3 divided by 4. Having gotten the k equals to 3 divided by 4, the next thing to do now is to fix in this value of k that we just obtained. We'll fix it into this formula a equals to k cube root of b. So to get our connecting formula now, all we need to do is to fix in the value of this k equals to 3 divided by 4 into this formula. And then we have a equals to 3 all over 4 cube root of b. This can simply mean 3 over 4 multiplied by cube root of b. This is the connecting formula. This is the formula that we use to determine our b from this question. The next question now, we are given the value of a to be 15 divided by 4, and we are asked to determine the b. So to do that now, all we need to do is to fix in the value of this a into this connecting formula. And then we have 15 divided by 4 at the a side, then equals to, we have 3 divided by 4 cube root of b. So the next thing to do now, we have 15 divided by 4 equals to 3 multiplied by cube root of b. So 3 multiplied by cube root of b is giving us 3 cube root of b divided by 4. So the next thing we need to do here now is to cross multiply. So when we cross multiply, 4 is multiplying 3 with this cube root of b. So we have 12 cube root of b equals to 4 times 15. That will give us 60. What we need to do now is to divide both sides by this 12 so that we can have cube root of b left there. Cube root of b will now equals to 60 divided by 12. the next thing to do now, so 12 will go in 60, 12 here 1, 12 here 5. So that means we have cube root of b equals to 5. So having gotten that cube root of b equals to 5, the next thing is for us, since we are to determine the value of b, we need to cancel out this cube root. So to cancel out the cube root, all we need to do is to say cube both sides. Then we're going to cube the left hand side and the right hand side. So we now have something like this: cube root of b raised to power 3 equals to 5 raised to power 3. So the next thing will be this cube will cancel out the cube root here, and then what we have left at the left hand side will be b, and then right hand side we have 5 raised to power 3, and our 5 raised to power 3 is 5 times 5 times 5, and that will give us 125 as we have it here. So our answer for b is 125. Let's also look at example 3. The distance covered by a falling ball varies as the square of the time taken. If a ball falls through 1,800 meters in 15 seconds, calculate the distance when the time taken is 13 seconds and time taken for a distance of 648 meters. If you look at this question, our connecting statement is given that the distance covered by a falling ball varies as the square of the time taken. So this is what we're going to do. We're going to say let the distance be d and let the time taken be t. The next thing for us to do now is to represent the statement here mathematically. It said the distance covered, and that is d varies as the square of time, that's square of t, that means t square. So we have d varies as t square. The next thing will now be we having d equals to kt square, where k is a constant. You know, this simply means k times t square. Okay, now we can make k the subject of the formula from here by simply dividing both sides by t square, so that we have our k equals to d all over t square. So for us to determine the value of k now, we are given the distance, which is this d. D is 1800 meter, and then the t is 15 seconds. So we're going to fix in these values into this formula for k. So we have k equals to 1800 divided by 15 square. So let's use our calculator to do that. 1800 divided by 15 square. So you're going to press, this is the square right here, 15 square gives us 225, and then you press enter or equals to, that will give the value of 8. So that means our k is equals to 8. So the next thing to do now is to fix in the value of this k into this formula d equals to kt square. Then our connecting formula will now be d equals to 8t square. So our connecting formula is this: d equals to 8t square. So this is the formula that will help us to now solve the problem. Calculate the distance when the time taken is 13 seconds. That's the first question. And the second question says calculate the time taken for a distance of 648 meters. So we're going to do the first one. For the first one, we are asked to determine the distance. We are given the time taken, which is the t, to be 13 seconds. So we don't know d. We're given the time to be 13 seconds. So we're going to fix in this value of t into this formula. And then we have d equals to 8 times 13 square. Okay, so let's use calculator to do that. 8 multiplied by 13 squared equals to, or enter, that will give us 1352. So we have our d to be 1352 meter. So the distance when the time taken is 13 seconds is 1352 meter. So let's look at the second question now. We are to determine the time taken for a distance of 648 meter. We are given the value of d to be 648 meter, and we are to determine the time. So we're going to fix in the value of this d into this connecting formula d equals to 8t squared, and we have something like this: 648 equals to 8t squared. The next thing to do now is to divide both sides. We'll divide the left hand side by the coefficient of the t square. The coefficient is the number beside the t square, and that is 8. Divide both sides by 8. So we now have 648 divided by 8 equals to 8t squared divided by 8. Left hand side being divided by 8 and the right hand side too. So we have 8 will cancel out 8 from the right hand side, and then we have t squared left at the right hand side. 8 can go here, 1. 8 can go in 64, 8, because 8 times 8 will give 64, and 8 can go in 8, that will give us 1. So at the left hand side we have 81 there. That means we have 81 equals to t square. In order for us to remove this t square, all we need to do is to say square root both sides, and that square root will cancel out the square on this t for the right hand side, and then we now have only square root on this 81 at the left hand side. So we have t equals to square root of 81. What is the square root of 81? Which two number are we going to multiply to give us 81? And that is 9. So our t is 9 seconds. So for this question, we are asked to determine the distance. We first of all get the connecting formula, which is d equals to 8t squared. We now use that formula to determine the distance here, which is 1352 meter. And then for the second question, we determine the value of the time, which is 9 seconds.